Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 7 to the power of 2x minus 1 is equal to 5 to the power of 2x plus 1. And we want to find our value of x here. So now for our solution, original equation was, again, 7 to the power of 2x minus 1 is equal to 5 to the power of 2x plus 1. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So this essentially distributes with both my exponents here. So in this case, I have 7 to the power of 2x minus 1. And although this is an addition, we can think of this as a is equal to 7, m is equal to 2x, and n is equal to negative 1. So if this is true, then I would have 7, which is a, to the power of m, which is 2x, times a, 7, again, to the power of n, which is negative 1. Now this is equal to 5 to the power of 2x plus 1, and now I'm going to do the same thing with 5 to the power of 2x plus 1. So again, our property was a to the power of m plus n is equal to a to the power of m times a to the power of n. So in this case, a is equal to 5, m is equal to 2x, and n is equal to 1. So now I have a to the power of m, so 5 to the power of 2x times a to the power of n, so 5 to the power of n, which is 1. So now putting it all together, I have 7 to the power of 2x times 7 to the power of negative 1 is equal to 5 to the power of 2x times 5 to the power of 1. Now, if I have something in the form a to the power of negative x, this is equal to 1 over a to the power of x. So if I had a to the power of negative 1, this would simply equal 1 over a to the power of 1, which is equal to 1 over a. So in this case, I have 7 to the power of negative 1. So that's going to equal 1 over 7. Now this is equal to 5 to the power of 2x times 5 to the power of 1, which is simply 5. So now, if I multiply 7 to the power of 2x with 1 over 7, actually, now if I multiply by 7 on both sides, these two would cancel out because these two are reciprocals, and if you multiply two reciprocals, that simply equals 1. So I get 7 to the power of 2x is equal to 7 times 5 to the power of 2x times 5. And now what I'm going to do is I'm going to divide both sides by 5 to the power of 2x. So then these two would cancel out. So now I'm left with 7 to the power of 2x over 5 to the power of 2x is equal to 7 times 5. Now you may be thinking to actually multiply these two, but I am actually not. I'm just going to leave them in the form they are. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, I have 7 to the power of 2x over 5 to the power of 2x. So we can think of a as 7, b as 5, and m as 2x. So then this would be 7 over 5 to the power of 2x is equal to 7 times 5. Now, if I take the log on both sides, I get log 7 over 5 to the power of 2x is equal to log 7 times 5. Now, an important property of logarithms is that if I have, let's say, log a to the power of b, I can actually move this exponent b to the front of the logarithm. So then this would be equal to b times log a. And the same thing actually works for the natural log to ln. So if I had ln a to the power of b, I can actually move this exponent b to the front, so this would equal b times ln a. And why this property is so important is that, let's say we have 7 to the power of x equals 9, right? And we obviously want to find the value of x, but in this case, x is an exponent, so it's really hard to find this. But if we took the log on both sides, then we can move this exponent to the front, and now, as you can see, it's a normal term, and we can solve for the value of it. So we can simply divide both sides by log 7. These two cancel out, and now I have x is equal to log 9 over log 7. So that's why this property is so important. So now going back, we had log 7 over 5 to the power of 2x is equal to log 7 times 5. Now, using this property, we can move 2x here to the front. So now I have 2x times log 7 over 5 is equal to log 7 times 5. Now, if I divide both sides by log 7 over 5, well, actually, before that, if I have something in the form log a times b, this is equal to log a plus log b. So log 7 times 5, this is equal to log 7 plus log 5. So now I can go ahead and divide both sides by log 7 over 5. So then these two cancel out, and I would be left with 2x is equal to log 7 plus log 5 over log 7 over 5. So now if I have something in the form log of a over b, this is equal to log a minus log b. So now I would have 2x is equal to log 7 plus log 5 over log 7 minus log 5. So now I'm going to divide both sides by 2. So then this would all be over 2. So now I finally get x is equal to log 7 plus log 5 over log 7 minus log 5 over 2. So that is my answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this simple problem that many people actually get wrong. So we have negative 2 squared minus negative 2 squared minus negative 2 squared. Now, to solve this problem, let's actually solve it with each individual term. So as you can see, we have 3 terms here. I'm going to first start by doing negative 2 squared. So if you guys know order of operations, which is PEMDAS, P-E-M-D-A-S, well, this is the order of operations in which you solve a mathematical problem. So P, this stands for parentheses, E, this stands for exponents, M, this stands for multiplication, D, this stands for division, A, this stands for addition, and S, this stands for subtraction. So as you can see, we first look for parentheses. And since we're solving this term first, there actually are no parentheses. So then we're going to go ahead and look for exponents. And as you can see, 2 squared, that's an exponent. So that's what we first do. We first do 2 squared. So we get 4, and then we have the negative sign after. So the value of negative 2 squared is negative 4. So now we have minus. Now let's do this one. So negative 2 squared. Well, as we already know, negative 2 squared is negative 4, right? So this would be negative 4 minus, now we have negative 2 squared. And, well, remember, both 2 and negative 2 squared, they're both equal to positive 4. So now this would equal 4. And as you can see, in this one, this is negative 4. However, in this one, negative 2 squared, this is simply just positive 4. And that's because the negative sign isn't in the parentheses. There's no parentheses, so the negative sign isn't included with the 2. So this is just normal 2 squared, and this is negative 2 squared. So now we could simply just simplify this problem and solve. Now we have negative 4. Of a negative is a positive, so plus 4, and we have minus 4. These two cancel out, and we are simply just left with negative 4. And this is our answer.